If you're asked to solve a log equation and there's only one log, okay, so you can either reduce it down to a single log or there's only one log given. Okay, I want to go through the steps that are necessary to solve this. All right? So the first step in a problem that looks like this would be to reduce it down to a single log on one side of the equation. Okay, so you're going to condense everything down. If necessary, you'll apply the properties that allow you to condense the logs, but you want to get your expression so there's only one log on one side of the equation. Okay, if you can do that, okay, so if that's the process that you can complete, your next step then will be to rewrite it in the form of its exponent. Okay, so if we convert this log into an exponent, we do that by taking the base of the log becomes the base of our exponent. Okay, to the power of 2 is equal to what's inside the log, 4x minus 3. Okay, once you rewrite it in this exponential form, what you can then do is solve the resulting equation. And so in this particular case, 5 squared is 25. Add 3 to both sides. You get 4x is equal to 28. And to solve for x completely, we divide by 4, and we get 28 over 4 reduces to 7. Okay. Now, your final step, like most of these, is to check your solutions. And the main thing that you want to check for on this would be to make sure that you don't have any non-positive values, okay, so non-positive values inside your log. So this value, this whole expression, can never be a 0 or a negative, and then this base of your log can never be a 0 or a negative. So when I plug in a 7 here, I get 8 times 7 is 28 minus 3 is 25. Okay, that's consistent. If you went even further, you could actually test it. Log base 5 of 25. And see, is that equal to 2? Well, 25 is 5 squared. The power of 2 comes out front. Log base 5 of 5 is 1. So you do check that 2 equals 2 on that. All right, so I want you to try this one here and see if you can come up with the solution for this, please. All right, condense it down to one log. It's already done. Okay, rewrite it in its exponential form. So we're going to take our base, same base as our log x, to the power of 2, set it equal to 36. Solve the resulting equation. When we solve this, we extract the square root. We get x is equal to positive or negative 6. Remember, when you extract the square root, you do have to take into consideration the positive and negative root. And here, when we check our solutions, if we plug either of these solutions into our original form, do we get a negative inside our log or a negative as the base of our log? Yeah, so the negative 6 is extraneous. The only one that works here is going to be the positive 6. And so there is only one solution here, and that solution is 6. Okay. So try this one last problem, please. And see if you can solve this equation for me. So if you condense this, you could either move this power of 4 up to apply to both the 3 and the x, or even more simply, treat it as an equation. What can you do to both sides of this equation to simplify what you're working with? Just divide by 4, right? So these factors of 4 cancel. 4 goes into 20 how many times? 5. And now you can rewrite the exponential form. We take our base of 3 to the power of 5, set it equal to the value inside your log, 3x. And now, if you don't know what 3 to the 5th is, that's fine, because what we can do here when we solve for x is just divide both sides by 3. And 3 to the 5th divided by 3 to the 1st is actually equal to 3 to the what? 4th. And what is 3 to the 4th? Kind of like saying 3 squared squared. 3 squared is 9 squared is 81. Right, and so you get your solution of 81. When you plug 81 back into the original expression, do you get a negative value or a 0 inside your log, or the base of your log? No, so that means it's consistent.